All right, moving on to example 7. Now we're talking about central angles of a circle, and the two key points with central angles of a circle. A central angle is any angle whose vertex is at the center of the circle. Right? The second thing about central angles is that the sum of all the central angles, or to be more specific, all the non-overlapping central angles, sum up to 360 degrees. So in this circle, right, we have three central angles. We have this orange one, which we're trying to find, right? And then this green central angle of 130 degrees. All right, and then we have this red central angle, which is a right angle. Right? The sum of those central angles are going to sum up to 360 degrees, right? There's 360 degrees, right? In a circle, there's 360 degrees rotated, right, around a point. All right, so 130 and 90, that gives me 220. So 220 plus x equals 360. And then if I do my algebra correctly, I back out 220 from both sides. I get x equals 140 degrees. Moving on to example 8, we're talking about different types of arcs and finding their measure, their degree measure. So we have minor arcs, major arcs, and semicircles. So the first arc we're looking at is arc GH. All right, so all an arc is a set of points that are between two endpoints. So arc GH, right, my 2 points are G and H, my endpoints, and the arc represents all the points between those two endpoints. Right? And since only 2 letters are named, this is going to be a minor arc, and also it's less than 180 degrees. Right, so this is a minor arc. And the nice thing about the measure of a minor arc is that it's equal to the measure of the central angle that intercepts it, or the angle, right, that it's inside of. So notice how the arc is inside angle or central angle GKH. Right? So the measure of arc GH is going to be equal to the measure of central angle GKH, or it's going to be equal to 122 degrees. Moving on to part B, right? The measure of arc GLH. Now, when we use 3 letters to name an arc, usually we're talking about a major arc, and a major arc is a set of points that is more than 180 degrees. Right? So looking at GLH, the first and last letters of the name of the arc are the endpoints. All right, so we got G and we got H. Right? And then the third letter, or the middle letter, right, is in between G and H. So here's L. All right, so my arc is going to go G to L, then to H. Right? And that's going to be a major arc. Now notice, what's really cool about the green major arc and the purple minor arc, right? In a circle, there's 360 degrees. And notice, right, my minor and my major arc, right, sum up to 360 degrees. So to get my major arc, I'm going to do 360 minus the minor arc, the measure of arc GH. So 360 minus 122, and that should give me, right, the measure of arc GLH should be 238 degrees. All right. And part C, we're talking about arc GLJ. Now again, it's 3 letters, so it looks like a major arc. We're starting at G, right? And the other endpoint is J, and the third point is L. So I go G to L to J in that order, right? And what I notice is that GJ, right, those are the endpoints of a diameter. Right? So when the endpoints of my arc are the endpoints of diameters, I have something called a semicircle. Right? And all semicircles are 180 degrees. So the measure of arc GLJ is equal to 180. Okay, moving on to example 9. Example 9 deals with congruent arcs of a circle. So pretty much the theorem in the converse state is if two central angles of a circle are congruent, their arcs are congruent. And conversely, if two arcs of a circle are congruent, then their central angles are congruent. So in example 9, they want us to find the measure of arc HD, this purple guy. Put a question mark there. And they give us two congruent angles. They tell us that this green angle, this green central angle, HCG, is congruent to this orange, right? This orange angle, DCE, right? And I don't even think they really needed to give that to us. I think those are central angles, but it's just nice to look at. All right, so we're given two pairs of congruent central angles. So that means, right, that if arc DE is 20 degrees, arc HG will also be 20 degrees. All right? Because if the central angles are congruent, their arcs are congruent. So arc HG will be congruent to arc DE. All right, and if DE is 20 degrees, that means that arc HG is 20 degrees. All right. The next thing we look at, we're not told, but let's look at GD. All right, arc GD is a semicircle, which is equal to 180 degrees. And that semicircle is made up of a green piece of 20 and a purple piece, which we're trying to find out. So GD, which is 180 degrees, is equal to HG, which we know is 20 degrees, plus HD, which we're trying to figure out. All right, we do some real simple algebra, right? HD is equal to 180 minus 20, or the measure of arc HD is equal to 160. Example 10, we're going to use arc addition postulate to find missing arc measures. And this is real similar to segment addition, where a segment can be made up of smaller segments. Same thing with an arc, right? You could have an arc that's made up of smaller arcs. So before we start finding our two different arc measures, let's look at the central angles that are given. So we're given two central angles, right? So, right, a central angle, right, is equal to the measure of the arc it intercepts. So that 63-degree central angle cuts off arc AE. So arc AE is going to be 63 degrees. And then we also have a 90-degree central angle, right, angle DFE, right, and that's gonna intercept arc DE, which is gonna be 90 degrees, right? So the measure of a central angle is equal to the measure of the arc it intercepts. So let's find the measure of arc AED, right? So arc AED, right? Usually when we see three letters, we think it's a major arc, but that's not necessarily the case. So arc AED starts at A, right, and ends at D, right? And then E is in between A and D. So it goes A to E to D, right? And that green arc, right, is made up of the orange arc, right? So the measure of arc AE, right? And it's also made up of that red arc, right? Arc DE. All right, so when we add the orange arc of 63 to the red arc of 90 degrees, right, we're going to get an arc measure of 153 degrees. So the measure of arc AED is 153 degrees. Right. The next arc we're going to look at is arc ADB. So again, we're going to start at A. We're going to end at B. All right, those are my endpoints. And then D's got to be between it. So it's got to go to A to D, all right, to B. All right, so we're looking at this big brown arc. All right, and we look at that. We got to be a little creative here. There's a couple different ways to do this. The way I like to look at it, I like to look at it as, right, it's made up of this orange arc, AE, which we know is 63 degrees. All right, and it's also made up of this purple arc, right, EB. All right, and what's really nice about EB is that EB is a semicircle, right? Because segment BE, right, is a diameter. Right? And all semicircles are 180 degrees. So the measure of arc ADB is going to be 63 plus 180, which is 243 degrees. The measure of arc ADB. All right, and on to our last problem of the problem set, example 11, finding the arc length. So they asked us to find the length of arc ZY, and we already know that its arc measure, its degree measure is 75 degrees. But it's not asking for the degree measure, it's actually asking for its length, a linear measure. And the arc length is related to the circumference of the circle, right? Because if you took all the arcs, right, that go all the way around the whole circle, right, that would sum up to the circumference, right, the distance around the circle. So what we need to do is we need to find, right, what fraction of the circle or what fraction of the circumference is contained, right, in arc ZY. Right, so we have a real simple formula that says arc length is equal to the central angle over the total 360 degrees in a circle, right, that's the fraction, times, right, the circumference of the circle, right, which is 2 pi r or pi d, or, right, we're just going to call it the circumference. All right, so, right, we don't know what our arc length is, right, so that's going to be our x, right. Our central angle is 75 degrees, so 75 over 360 times 2 times pi times the radius, right, of 4. Right? And really right here, guys, we're just plugging this into our calculator. All right, so all right, so what we're going to do is we're going to do 75 divided by 360, right, times 2 times 4 times pi, right, and that's given us, right, an arc length of 5.24 inches. So arc length of ZY is equal to 5.24.